Hello and welcome to the wolfSSL live webinar, All the Cool Things We've Added This Year, presented by wolfSSL Senior Software Engineer, Eric. My name is Shizuka and I will be moderating the webinar. All attendees will be in listen-only mode. If you have a question, please use the Q&A box. We will host a Q&A sessions following the presentation. The webinar will also be recorded and made available on our YouTube channel shortly after the presentation. I invite you to follow us on Twitter at wolfSSL, as well as our other socials. Also, feel free to email us if you have any additional questions. And now I would like to give a brief company overview before we move to the technical presentation. Today, wolfSSL secures over 2 billion connections. We have more than 1,000 OEM customers and dozens of resellers. wolfSSL is made up of over 50 dedicated employees, most of which are engineers. This progress is, of course, supported by a strong partner network that we are proud of. Since the beginning, our engineering team has developed several embedded security products, including wolfCrypt with DO178 support, FIPS certification, and a FIPS-ready offering MQTT up to the V5 specification, SSH v2, TPM 2.0, a secure bootloader known as a wolfBoot, as well as Java wrappers and JSSC support and a commercial support for Coral. All of these offerings are accompanied by maintenance and support plans up to the 24/7 level. We also offer full service consulting. And now I would like to turn it over to Eric to talk about all the cool things we've added this year.
Excellent. Thank you very much, Shizuka. Hello, everyone. Welcome to the 2023 wolfSSL Project Feature Review. Today, we'll be highlighting some of the project features that the wolfSSL team has accomplished, as well as some up-and-coming features. We spend a lot of time developing the latest innovations in cryptography and security. We participate in roundtable discussions at conferences. We read volumes of specifications, all to make sure that wolfSSL has the most secure, best tested security available. So we'll begin with the wolfSSL project. wolfSSL is the library which implements the TLS and DTLS protocols, certificate handling and management, as well as programming language wrappers. Additionally, it contains the OpenSSL compatibility layer, which allows applications to build with wolfSSL instead of OpenSSL. wolfSSL was one of the early adopters of the TLS 1.3 protocol, all the way from its early drafts to the final ratified version. Since then, we've been busy adding features and extensions to round out the project. In early 2023, wolfSSL added support for the encrypted client hello draft extension for TLS 1.3, formerly known as the encrypted server name indication. The encrypted client hello, or ECH extension, encrypts the client hello message meant for a TLS 1.3 server and sends it as an extension of an outer client hello that has the sensitive fields removed. This encryption obfuscates the sensitive parts of the client hello, such as the server name indication, or SNI, from any passive observer that may capture the client hello. ECH makes use of HPKE, or hybrid public key encryption, which is a key encapsulation and encryption standard that allows two parties to derive a common secret and encrypt and decrypt messages using that common secret. We were also one of the very first libraries to implement DTLS 1.3. In fact, OpenSSL has still not even released a timeline for an expected implementation of the DTLS 1.3 protocol. Meanwhile, wolfSSL is steadily improving our project and adding features. wolfSSL implements support for both client-side and server-side DTLS. The server side requires extra attention when it comes to denial of service or DOS attacks. One way to mitigate DOS on DTLS servers is to operate statelessly until a cookie exchange is completed with a peer. The cookie exchange is implemented in all versions of DTLS. DTLS 1.2 uses a special hello verify request message, while DTLS 1.3 uses the TLS 1.3 hello retry request with a cookie extension. The trick is to parse the initial client hello without maintaining state. In wolfSSL, we implemented parsing the initial client hello without maintaining state at all. We made significant improvements on how we parse and encode ASN1 data, like certificates and keys. Parsing X259 certificates and RSA and ECC keys is critical. In fact, some vulnerabilities come from not checking the validity of the encoding correctly. Reading outside the encoded data can result in a crash of your application or device. To simplify the code and make it as safe as possible, templates have been introduced that describe the format of data to be parsed or encoded. Using common functions that check the validity of ASN1 structure on parsing means fewer places for bugs. It also means a lot less code. Another component of wolfSSL I mentioned earlier is language wrappers. The library is implemented in C and assembly primarily, but we have written wrappers to make building for your application as seamless as possible. Recently, we expanded the language wrappers by adding an Ada Spark binding that enables Ada applications to use post-quantum TLS 1.3 encryption through the wolfSSL embedded SSL TLS library. This also opens the door to obtaining FIPS 140-3 and DO 178C certifications for any applications that use TLS for their encrypted communications and makes them quantum safe. Lastly, we'll delve into the history of wolfSSL a bit. The original implementation of wolfSSL was named COSL, as in C language, yet another SSL. Around 2015, the name was changed to wolfSSL, and a compatibility layer has been maintained up until now to map the COSL API to the wolfSSL functions. This year, we removed the COSL compatibility layer, and after providing a deprecation notification about 2 years ago. So see you later, COSL. wolfCrypt contains all the algorithms and ciphers used by the wolfSSL code. wolfCrypt is distributed with wolfSSL, but it is capable of being compiled standalone for applications that might need the cryptographic functionality without all the TLS bits. We are constantly adding support for the latest cryptographic capabilities. As many people know, the Chinese government regulators are now mandating the use of SM2, SM3, and SM4 in critical systems, including automobiles, avionics, power systems, and communication systems. Since many of our customers are multinationals that do business in China, they have been requesting the addition of these algorithms in wolfSSL products. So this is really great news for our customers selling into Chinese markets. Recently, more and more resources have been devoted to the development of quantum computers. So much so that commercialization of cloud quantum computing resources has already begun. While the current state of the art is still not in the realm of being cryptographically relevant, some threat models, such as harvest now, decrypt later, mean that preparations need to happen sooner than the appearance of cryptographically relevant quantum computers. The wolfSSL team has integrated experimental post-quantum cryptographic algorithms into the wolfSSL library. This was done by integrating with the Open Quantum Safes team's liboqs. Additionally, we've added support for the LMS and HSS post-quantum stateful hash-based signature out schemes to our wolfCrypt embedded crypto engine. This will be achieved by experimental integration with the HashSigs, LMS, and HSS library, similar to our previous liboqs integration. Next up, we'll review our progress on the FIPS 140-3 certification. So FIPS, Federal Information Processing Standards. It's a mandatory standard for the protection of sensitive or valuable data within federal systems. FIPS 140-3 is an incremental advancement of FIPS 140-2. Among the changes for 140-3 are conditional algorithm self-tests, or CASTs, where the algorithm self-tests are only performed if they're being used in the application. The pre-operational self-test is now faster, as all the algorithms are not tested until they're needed. This helps with startup times, as the public key self-testing can be quite time-consuming. The self-test can be run at appropriate times for your application startup. Also, there is the additional testing of the DRBG entropy sources. So here's the news. wolfSSL has been chosen by our lab to participate in a pilot program, which will fast-track wolfCrypt FIPS certification. Part of this effort required implementation of the degraded mode of operation, which basically means that if one algorithm should fail the self-test, then others that have passed will still work in the FIPS module. This could happen in a low memory environment, maybe like where the smaller key sizes work, but larger ones consume too many resources. Key derivation functions are consumed by TLS 1.2, 1.3, and SSH. The certification process requires separate tests for each protocol that uses KDF. We will support KDFs in all three in our new FIPS 140-3 certificate. The insecure triple DES and MD5 algorithms have been removed from the wolfCrypt FIPS module. We already talked about the conditional self-tests and how they benefit the application. The kernel module provides the entire wolfSSL API natively to other kernel modules, allowing fully kernel resident TLS DTLS endpoints with in-kernel handshaking. Configuration and building is simplified using a single option and can be set up for cryptographic self-test at load time, including full FIPS 140-3 core hash integrity verification and self-test. And I'm happy to announce that we will be submitting to the pilot program this week. This could mean a wolfCrypt FIPS 140-3 certification as soon as October of this year. So wolfBoot is a portable, OS-agnostic, secure bootloader solution which uses wolfCrypt for firmware authentication and provides firmware update mechanism. Due to the minimalistic design of the bootloader and the tiny hardware abstraction layer API, wolfBoot is completely independent from any OS or bare metal application and can easily be ported and integrated in existing embedded software projects to provide a secure firmware update mechanism. wolfBoot offers a simplified measured boot implementation, a way to record and track the state of the system boot process using a TPM or trusted platform module. This record is tamper-proofed by special registers in the TPM called platform configuration registers. Then the firmware application, RTOS or rich OS, such as Linux, can access that log of information by reading the PCRs of the TPM. wolfBoot can interact with TPM 2.0 chips thanks to its integration with wolfTPM. wolfTPM has native support for Microsoft Windows and Linux and can be used standalone or together with wolfBoot. The combination of wolfBoot and with TPM gives the developer a tamper-proof, secure storage for protecting the system during and after boot. The Intel FSP provides a set of common firmware services that can be used for memory initialization, power management, and silicon initialization. wolfBoot accesses these services by invoking machine-dependent binary code provided by the Intel FSP in the form of binary blobs. We additionally provided TPM integration and support for the ATA security feature set. We discussed post-quantum in wolfCrypt a few slides ago. wolfBoot is also benefited by adding support for post-quantum signatures. At present, support for LMS and HSS signatures has been added, we even have examples for stateful hashing available for the Crypto 4A QX Edge. ARMv8M microcontrollers support hardware-assisted domain separation for running software. When wolfBoot is configured, a more complete set of components of the wolfCrypt cryptography library are built into the bootloader, and they can be accessed by applications or OSs running in non-secure domain through non-secure callable APIs. This feature is used to isolate the core crypto operations from the applications. Part of that is a standard PKCS11 interface, including a storage for PKCS11 objects in a dedicated flash area in the secure mode. That means that applications, TLS libraries, and operating systems running in the non-secure domain can access wolfCrypt through a standard PKCS11 interface and use the crypto library with pre-provisioned keys that are never exposed to the non-secure domain. We've also added ELF 32 and 64 image support, which features the ability to load an entire flash image to RAM. Since wolfBoot is so simple to port, we are continually adding new targets supported out of the box. These include recently OctoSpy, the Renesas RA6M4, NXP's IMX RT 1064, and even Intel's Tiger Lake platform. Next, we'll talk about MQTT. So wolfMQTT is a library, it's a client library for IoT applications that use the MQTT protocol. We currently support versions 3.11 and 5.0 of the MQTT specification, in addition to the sensor network specification, MQTT SN. wolfMQTT uses wolfSSL for securing the connection to the broker service, whether that's AWS, Azure, HiveMQ, Mosquito, or some other solution. Recently in the MQTT project, we added support for securing MQTT SN client using DTLS. This was tested against the PAHO MQTT SN gateway project. Additionally, we added a new dynamic memory option for handling MQTT v5 properties. This is optional as the wolfMQTT library otherwise has no memory allocation calls. We added support for Zephyr OS and some examples. We also added an STM32 cube pack to make it easy for STM32 developers to implement an IoT solution. We updated the AWS example to take advantage of the recent addition of MQTT version 5.0 protocol in the AWS cloud. And we just added an ESP32 port, an example. So wolfSSH, it implements the SSH version 2.0 client and server support, as well as SCP and SFTP for file transfers. Because wolfSSH is powered by wolfCrypt, wolfSSH has access to all the platforms with hardware cryptographic acceleration that are supported by wolfCrypt. Recently, we introduced wolfSSH-D. An SSH daemon is the server which listens for clients. The original implementation was for Linux, and we've expanded that with a Windows port. As with other projects, wolfSSH is also benefiting from post-quantum support in wolfCrypt. As a matter of fact, Amazon recently interop tested it using PQ hybrid key exchange in transfer family SFTP using wolfSSH. We've also added new ports, including an STM32 Cube IDE pack for STM32 targets. The SSH client example application has gotten some attention recently, getting a polish and some new features. We also continue to expand the security options available in wolfSSH by adding support for RSA signing with the excuse me, SHA 256 and 512. So TPM is our implementation of a library interface to the trusted platform modules. If any of you have read through the TPM 2.0 specification, you'll understand how useful a succinct API and plentiful examples could be for writing applications that access a TPM. As I mentioned previously, a lot of effort has gone into taking advantage of the TPM feature set in wolfBoot. This includes measured boot, root of trust, and secret sealing. The TPM offers wolfBoot root of trust. In other words, it provides authentication and tamper protection. It accomplishes this by securely storing keys in non-volatile memory in the TPM, which are only accessible using authorization. Similarly, externally stored secrets can be protected using a signed policy. In this scenario, secrets are sealed with a public key. Only after a policy is verified, those secrets can be unlocked. This fixes an issue with PCR brittleness, since now an update can include a new signed PCR policy. Parameter encryption is another security measure offered by TPMs. We've recently added support for the ECC parameter encryption. Also, private keys can now be imported using a custom seed. For example, using the same KDF seed for the private key between multiple instances of the TPM. We also added support for memory mapped IO addresses to a TPM, which supplements the existing SPI, SPI, and I2C interfaces. So testing is a hallmark of wolfSSL projects. We spend an inordinate amount of time adding new tests and improving our existing test infrastructure. We all recognize the value of testing, and wolfSSL aims to continually improve our projects by exercising all possible configurations. One service we offer to our premium customers is adding their build configurations to our continuous integration scripts. This ensures that the configuration used by a customer is tested against all code changes, and new releases will work as expected or even better. To further enhance this, we now offer support for configurations made with the user settings header. It's as easy as adding the header file to our CI folder, thereby ensuring that all new versions of wolfSSL are already tested against your build settings. We talked a bit about wolfSSL's compatibility layer for OpenSSL. There are actually several ways to replace OpenSSL in your application, another of which is using the Wolf Engine or Wolf Provider. This allows an application using OpenSSL to swap out the cryptography engine or provider, depending on the OpenSSL version, with a FIPS certified wolfCrypt module. We've greatly expanded the testing around these interfaces. Our Java wrappers and components are now tested against the Sun JSSE test suite. We also introduced a RAM usage test, which helps identify excessive memory use and prevent bloat. Lastly, we love open source projects, and we regularly add new projects to our repertoire of wolfSSL secured OSP. These projects are used the world over to power the infrastructure of the internet and IoT. They use wolfSSL because it provides a proven solution capable of being optimized and configured for any platform. We've recently added new integration tests for STunnel, Hitch, MicroPython, and Kerberos. So what's next? We'll never stop and rest on our laurels like some other security libraries. We will continue to innovate and improve with every line of code we write, review, test, and share with the world. We are building a new component named wolfHSM, which will provide an abstraction for hardware security modules. Our implementation will be unique in that wolfCrypt software implementation will fill in the gaps for any algorithms or ciphers that are not supported by the HSM. FIPS also validates entropy, and after completion of our 140-3 certificate, we'll submit a solution for certified entropy in wolfCrypt FIPS. We are also well underway with our next post-quantum project to support XMSS. We are looking to provide an end-to-end MQTT sensor network solution by developing the gateway component. Also in progress is support for Zephyr OS and wolfSSH. And very soon we'll complete the open source project port for Memcached. And as always, we're interested to hear what you are working on and what we can do to help. So tell us what platforms you would like us to add. And with that, we'll open it up to questions.
I do have a question. What alternative to TLS would you recommend for application when low latency is required, but network might be externally exposed, for example, embedded area?
So an alternative TLS, so basically what you're looking for there probably is in a low latency. You're probably going to look into to tweak the different algorithms and ciphers that are going to be used with TLS. You could also use something like DTLS, of course, if you've got a UDP network.
There's another question. Do you have a support for Java or C++ only?
Yeah, absolutely. So we have a full Java wrapper, including JSSE and Java providers. Those are available in the wolfSSL repository also.
Another question, do you have a patent already published against wolfSSL?
Patents. So wolfSSL is not a patented project. It is an open source, so it is governed by GPL, at least the open source version, but we're dual licensed, as Shizuka mentioned earlier. So we actually have a commercial version that we can license, that we can provide. That's because we own all of our own IP. We developed everything ourselves. We're not a fork of another project.
Another question, can wolfBoot work without TPM hardware support?
Yeah, certainly. So TPM is only there as a supplementary way to store private keys and secure keys. So you can absolutely, we've got tons of examples on how to use wolfBoot.
Another question, STM32 support is provided out of the box or additional component should be requested for it?
So yeah, you're basically, if you're using STM32, you're probably going to be using the STM32 Cube IDE, which is really neat. It packages all the different components into just cube packs, and you can import those whenever you need to access a certain functionality or API. So you would want to use the Cube IDE to provide support for the drivers and BSPs and stuff like that.
Another question, can wolfBoot work with TFTP?
I guess you're talking about for transferring the image, the boot image over. Yeah, absolutely. You could. It's kind of like in the application. So the application, there's only a couple interfaces from the application to wolfBoot itself, and one of those is going to allow you to store the image, and you could use TFTP for sure.
And another question, can wolfMQTT use OpenSSL as an experimental debug purpose library or wolfSSL only?
So I guess you're talking about securing the MQTT connection from the client to the broker using OpenSSL. So that's currently not supported in the MQTT client library. I don't know why you'd want to. It's wolfSSL is a much better solution, especially for IoT focused clients where you've got resource restrictions.
Another question, what are license limitations of using wolfSSH? Can the binary be installed and used for commercial purpose internally? Can it be distributed as a part of hardware modules?
Good question. I would invite you to email us at facts@wolfSSL.com to discuss a licensing issue like that.
Another question, do you have a MQTT bridging functionality building MQTT client?
So bridging is not currently supported because it's typically a broker capability. So basically when you're bridging, what you're doing is allowing a set of clients that are connected to that broker to actually talk to another broker that's somewhere else. So that's more on the broker side, and no, we have not implemented that.
I do have another question. What are licenses limitation for embedded hardware modules using MicroPython with wolfSSL library?
Again, I'm going to deflect license questions to our business director team, and you can reach them at facts@wolfSSL.com.
Okay, if you guys, it was the old question I had. So thank you, Eric, for hosting an informative webinar. Oh, yes. So someone said thank you very much for the great webinar and Q&A. And
Very welcome.
hey, thank you, Eric, for hosting an informative webinar, and everyone for joining the webinar today. Please don't forget to follow us on Twitter at wolfSSL and other socials. Thank you again, and see you next week.
Excellent. Bye, everyone. Cheers.